Right, again, we have a 1 over x squared parent function, but now it's been reflected over the x-axis. It will also have been dilated vertically by a factor of 3, translated right 2 and up 4. So right 2 and up 4 would put my asymptotes intersecting at the ordered pair 2, 4. So I'm going to draw that in. I'm going to use the line tool this time. So here's a horizontal asymptote at y equals 4 and a vertical asymptote at x equals 2. Again, they should be dotted, but this is just as the easy way to do it by hand. We're now going to realize that this is 1 over x squared. So my important points would typically, and I'll do this in a different color, be over 1 and up 1 in both directions, right and left. However, it's dilated vertically by a factor of 3 and reflected over the x-axis, which after the translation is the line y equals 4. So instead of going over 1, up 1, we'll go up 3 times that amount, over 1, up 1, 2, 3, because 3 times 1 is 3. But really, we actually, instead of going up 3, we want to go down 3, which will reflect it over the horizontal asymptote. So over 1, down 1 was the reflection, dilating that times 3, 1, 2, 3, puts me at 3, 1 as my point. All right. Let me make that a little bit wider. Right. And same thing over here. Instead of going over 1, up 1, the reflection could go over 1, down 1. And you could do the reflection or the dilation first. It doesn't matter. I'm going to reflect it first this time because I have more room to work with going down than up. And instead of going down 1, we're going to multiply that by 3. 1, 2, 3. So here are your 2 important points at 1, 1 and at 3, 1. So I'm going to sketch in the graph as best I can, making sure to approach the asymptotes correctly. And this is as accurate as we can. This is accurate enough to get full credit, as long as you go through the 2 important points and you approach the asymptotes in the correct way. If you feel like when you draw it, it's way off, then erase it and start over. And that would be what our graph might look like. So let's go ahead and answer the questions. The horizontal asymptote we already discussed was the line y equals 4. The vertical asymptote was the line x equals 2. Domain, in this case, the domain is all real numbers. I use all these x values except for 2. Again, if I plug 2 in for x, I'd have 2 minus 2 is 0, which makes it -3 divided by 0 squared, or -3 divided by 0, which is undefined. So I will say all real numbers. I'll need to copy this equal sign. So I'll say all real numbers as long as x is not equal 2. Now for the range, this is where the range for the x squared functions is a lot more difficult because it's not just y can't equal 4, which it would have been if it was 1 over x, because I don't use the values above y equals 4. So I can still include all real numbers. That's always a good idea, but it's all real numbers as long as they are less than 4. So as long as y values that are less than 4. It would be a major mistake if you said less than or equal to 4. You do not want to include y value of 4 because that's an asymptote that will only be approached and never actually touched. All right. If you're using interval notation for this, just as a heads up, some students have a problem using interval notation when they're using values that are less than a certain number because their I goes from 4 down to -infinity. So they use intervals from 4 to -infinity, but we always read from bottom to top, the same way we read left to right. So if I was using interval notation, I would have had to have gone from -infinity up to the value of 4. And again, we do not want to include 4, so this is an open bracket, not a closed bracket. So both of these say the same answer, whichever way you prefer. The end behavior, again, I will cut and paste. I will copy. Oops, remember we have to be in the math form to do that. All right, and both end behaviors will approach that horizontal asymptote of 4. So therefore, this is 4. And then also, I'm running short on time, so I will do this and just change the negative to a positive. This will also be 4.